In this lesson, I will explain how to construct a tiling using the TOPOSPro program. If we construct tiling for a zeolite, we should do it for the framework, containing only silicon atoms. So, in the initial structure, I should delete all cations and transform all oxygen atoms to the net edges. Now I am deleting calcium atom from the list. Next, I run compound, auto-determine, simplify adjacency matrix, remove all 0, 1, and 2 coordinated nodes. I have transformed the oxygen atoms to the edges. As you can see, now we have only 4 coordinated silicon atoms. The same procedure I can do for several compounds. I select compounds, run compound, auto-determine, modify adjacency matrix. Atom A will be all elements. Atom B, metal atoms. Bonds to change, valence, change to none. By the procedure, we have broken all bonds between metal atoms and other atoms. Now the metal atoms are 0 coordinated. Again, I should delete all 0 and 1 coordinated nodes and transform 2 coordinated nodes to edges. So I apply compound, auto-determine, simplify adjacency matrix, remove all 0, 1, and 2 coordinated nodes. As you can see, we have only 4 coordinated silicon atoms and may construct tilings for the frameworks. I run ADS, Options, Topology. I have to set all rings option. The option ensures that all rings up to size of maximum ring will be found. These rings are necessary for the tiling construction. When you set maximum ring size, you should set value more than the biggest ring in the tiling. Of course, you don't know exactly the size of the rings, so better set maximum ring equal to 12, because it is enough for most of structures. You should remember, the larger maximum ring, the slower calculation. If you set too small maximum ring, improper tiling cannot be constructed, then you should increase maximum ring size. Then I switch to the Tiling tab. I have to specify the maximal number of the tile faces. The maximum tile size, 200, is sufficient for most of the nets. I should check the Natural Tiles option. As you can see, the options Locally Strong Rings and Single Tiling turn on automatically. These 3 options ensure obedience of the tiling to the natural tiling rules. The rules and the algorithm for computing natural tiles are described in the supporting article. So I have set the options maximum tile size, natural tiles, locally strong rings, single tiling, and maximum ring, which are necessary for the natural tiling construction. I run ADS. It offers to select central atoms. These are the atoms to be taken into account during for tiling construction. I select all silicon atoms. Let's look at the output data. Here you see the information about atoms connection. Here is the topological information. These data were described in details in the lesson devoted to the TTD collection. Here TOPOSPro enumerates all rings and separates them to essential and inessential for construction of a tiling. The ring is essential if it is a face of a tile. This is the information about all tiles and its properties. Each line contains information about a tile. Number of vertices, number of faces, number of T-atoms in the ring, and number of the rings constructing tile. For example, this tile is constructed from 2 4-membered rings, 8 5-membered rings, and 2 8-membered rings. This description shows the inequivalent rings constructing each tile. These are geometrical properties of the tile. Here, the tiles constructing the natural tiling are shown in the stoichiometric ratio. The transitivity of the tiling shows the number of inequivalent vertices, edges, faces, and tiles in the tiling. D size is the number of primitive tetrahedra in the tiling. The larger is D size, the more complex is the tiling. This is the average number of T-atoms in rings. The dangling edges shows average number of the atoms bonds, which do not belong to the tile. This table summarizes main information about tiling. Ergo, we have considered all necessary options for the construction of the tiling. Let's consider additional options. The option Essential Rings for 3DT saves a CGD file which allows the 3DT program to draw the tiling. The Write Data to TNT option saves a TNT file which allows the Isochrist program to visualize the tiles. I turn on the option Run ADS and in the output window use the Image, Primitive, Natural Tiles option, which shows the Isochrist and the tint file data windows. Here we can see all tiles. If tile is typed in bold, you can press the Apply button and look to the tile. If not, you should press the Grow button until the tile gets typed in bold. Now let's consider the options on the Tiling tab. The Tiles by Hand option is used when you have to apply a rule. If on the output data you see information about the non-strong rings with negative curvature, you should keep in mind the essential rings and the rings with negative curvature. Then you have to turn off the natural tiles and the locally strong rings options. The option Tiles by Hand should be turned on. Now you have to select the essential rings and, in addition, the ring with negative curvature. So I select the essential rings 4A, 4B, 4C, 4D, 5A, 6B, 8A, and add the ring 8B. It is the ring with negative curvature. I press OK, then Cancel, because I do not need to select the rings anymore. Now we have constructed tiling using the rule. It should be noted that among 235 zeolite frameworks, only in 6 frameworks the tiling was constructed using the rule. This option constructs dual nets. The nodes of the dual net correspond to the tile center. Edges are the bonds between nodes. The dual net corresponds to the system of cavity centers and channel lines. For more information about dual nets, you may address to the supporting article and our webinar, Zeolites, Comprehensive Analysis of the System of Cavities and Channels with a Tiling Method. So I turn on the option Run ADS, select Central Atoms. The output data are the same in this case. ADS creates a new database to save the data on the dual net. there are pseudo-atoms ZA, which correspond to the dual NAT nodes. All tiles are typed in the tab command. I run isochrist to see the dual NAT. The black nodes correspond to the dual NAT. Let us determine topology of the dual NAT. Ergo, ADS, options, topology, classification, run. The central atoms are all Z pseudo-atoms. As you can see, it has the DEHD topology. The option Determine Tile Topology is used for classification of the tiles. If the option is active, ADS will compare tile topology with the reference topologies from the TileLib library and will show the tile's name in the output data. The TileLib file is located at the path shown in the window Polyhedron library. I turn on the option and run ADS. As you can see, the tiles' names are typed in the output data. The option Save Tile Topology writes names of the new tiles in the TileLib library. As you can see, now Topos has found a new tile and offers to save it in the TileLib. In this case, you should choose the tile's name. This option allows you to create your own library of tiles. This option allows us to construct separate tiles. It is very useful if tiling cannot be constructed. For example, the structure of fullerene does not have any 3D framework, so the tiling cannot be constructed, but a separate tile corresponding to the fullerene molecule can be constructed. The option Unessential Crossing should be used if ADS cannot construct tiling and the output data contain information about inessential crossings. In this case, you should check the option and try to construct tiling again. The 3D Surfaces option looks for 3D surfaces located inside the structure. Here is the information on the rings, which form the surface. The window maximum set size is used for construction of not-natural tilings. It is active if you turn off the natural tiles and the single tiling options. In the window, you should set maximum number of the inequivalent faces in the tiling. This value should be less than the number of rings in the natural tiling. In this natural tiling, there are 13 inequivalent faces, so I will construct tilings with up to 5 inequivalent faces. As you can see, here we have 2 tilings. You can use all these options for construction of tilings for several compounds. In this case, you should select the compounds and choose central atoms in the Continuous tab. Now we have tilings and their properties for all compounds. So, in this lesson, we have considered all options of the ADS program, which are using for the tiling calculation. For more information about possibilities of the program package TOPOSPro, you may address to our lessons and webinars in our website sctms.ru.